Hey everybody, Mr. Mac here. 3.5 parallel and perpendicular lines. And so this section is just preparing us for 3.6, which is using the distance formula and the distance between a point and a line. And so we have to do some things with parallel and perpendicular lines before we get there. So how do we determine if a line is parallel, perpendicular, or neither? Well, let's take a look at this site here called geogebra.org. This is the classic version, what I like to use. And we are going to input, let's see, what are we going to do? How about we just make a line here? And I'm going to do that. Here we have a line with a slope of y equals x plus 2. So the 2 is the y-intercept, and the slope is up 1 over 1. In fact, why don't we just make this have a slope of 2. So we're going from a y-intercept of 1, and the slope is rise 2, run 1, so this has a slope of 2. Now, I'm going to, there's a lot of great tools up here. I'm going to go to perpendicular line, and let's do parallel line first. So we're going to select a point in a parallel line. So let's get a point here first. So I'm going to go about right here. I'm going to put a point at -1, and let's select parallel line. So select point and parallel line. I'm going to select this point and then this parallel line, and there we go. So we have two lines, y equals 2x plus 1, which is this first one, and let's make this, how about we make this blue, and we have the second line here, let's make this red, and these two lines are parallel. In fact, let's change the settings on this to be y equals mx plus b. And so now, what do we see that these two lines have in common? They have the same slope, 2 and 2, and they have a different y-intercept. Now, I'm going to change this point here on B, and it will change the red line also because I made that construction, so it does that. So how about we go there? Let's do that. Now we have a slope of 0.33. Well, that's 1/3, right? Up 1 over 3, that's 1/3. And then this line right here, this red line, also has the same slope of 1/3. How about I change the slope here so that the blue line has a slope of -1 over 2, and the red line has a slope of -1 over 2. Slopes don't change. Okay, so we know that if slopes have the same, if lines have the same slope, then they will be parallel. Now, they can't be parallel if they're the same line. So if I were to make the y-intercepts the same, then no matter what I do here, you see these lines are the same now. And these aren't parallel. In fact, look, the line is kind of purplish, right? Because red and blue together. So let's get rid of this one. And let's make a perpendicular line. And let's put a point, how about here, through this point right there. Now, this is perpendicular through point C. And if I let's go change this into y equals mx plus b form now. And let's make this green. Okay. Now I'm going to change my slope. Let's go back to our original equation before, where we had y equals 2x plus 1. So blue line is y equals 2x plus 1. The green line has a slope that is different. So how would you describe this? This slope for the blue line is up 2 over 1, and then the slope for the green says negative 0.5. So what are we doing here? We are going down 1 over 2. Okay, down 1 over 2. So let's make this slope on the blue one 3 over 1, up 3 over 1. Now, the slope for the green looks like we go down 1 over 3. So the slope of the blue line is positive, the slope of the green line is negative. The slope of the blue line is up 3 over 1. The slope of the green line is down 1 over 3. All right. How about this one? The blue line slope is up 1 over 1. The green line is down 1 over 1. So we're seeing a pattern here, and it is that parallel lines have the same slope. Same slope, but with different y-intercepts. If they have the same y-intercepts, it's the same line. Perpendicular lines have negative and reciprocal slopes. So what is reciprocal? We have a numerator and a denominator, and so if we take the reciprocal of that, we are just writing the numerator in the denominator space and the denominator in the numerator space. That's a reciprocal. So it's got to be both, negative and reciprocal. So for number 1, y equals negative 2x plus 3 and y equals 1/2 x plus 3. Are these parallel, perpendicular, or neither? Well, the slope for the first one is negative 2 over 1. Slope for the second is 1 over 2. They're both negative. They're both reciprocal. Got to have both of these conditions. So these are perpendicular lines. And that's my perpendicular symbol. Looks like that. That's ugly. And there it is. Okay, number 2. We've got our first slope here is 4, or 4 over 1. And the next one is also 4 over 1. But we could see that our y-intercept for this one is negative 2, and our y-intercept for this one is 5. So the same slopes, and different y-intercepts, that means that these are parallel lines. That's an example of parallel. All right. So let's see, what do we do with number 4? So I'm going to leave 3 for you to do. You do 3. I'm not skipping it. You do it. Our slope for this first line is -3/1, and the y-intercept is 1. And our second line, our slope is 3/1, and our y-intercept is -1. So -3/1 and 3/1 are negatives of each other, but they are not reciprocal. So they're also not equal. -3/1 is not equal to 3/1. So what's the deal with this? This one is neither. So for number 5, I'm going to skip number 6, but number 5, we have to put these in y = mx plus b form before we can determine the slope and the y-intercept. So for this one right here, I have to subtract 2x to both sides. And then divide by -3. So it's going to be -2 over -3x plus 6 over -3. So this is going to be 2/3 x minus 2. And then this one, we're going to subtract 3x to y equals -3x plus 6. Going to divide by 2. -3 halves x plus 3. Okay, let's check the slope of this one is -3/2, and the y-intercept is 3. And this one, our slope is 2/3, and the y-intercept is -2. So the slopes are negatives of each other and reciprocal. So in this one right here, these lines, these are going to be perpendicular. All right. Everybody okay in there? A line goes through each pair of points to determine if the lines are parallel or perpendicular. Okay, so we need to do a little bit of work here. First thing we need to do is we need to find the slope of each equation and then the y-intercept. So slope is going to be the rise over the run. And the rise, another way of saying that is the change in y over the change in x. So this is delta, looks like a triangle, means change. So the change would be y2 minus y1 over x2 minus x1. So this is our first point, x1, y1, x2, y2. So we can say 6 minus 4 over 4 minus 2. I just substituted in right there. And that gives us 2/2, which is 1. So I've got y equals mx plus b. One way to solve this is to say, okay, I know that I have my m here is 1. So I'm going to put a 1 in there. And a y and an x, I know. I could use either the first point or the second point. Let's use the first point. So let's put 4 in for y, and let's put 2 in for x, and then we could solve for b. So we get 4 equals 1, because that's my slope, times 2 plus b. 4 equals 2 plus b. b equals 2. So my equation is y equals 1x plus 2. Now I need to do that for the next line. And I just need more room, and I'm going to erase this one because you guys are going to do that. So let's just erase that. And so point 2, we're going to do this one over here. Same thing. So my slope is going to be y2 minus y1 over x2 minus x1. So y2 is -1 minus a -2. Okay, so here's my y2 and here's my y1. Over x2 is 6 minus 4. So -1 minus a -2, this is going to become a plus right here. So this is -1 plus 2 over 6 minus 4 is 2. So this is going to be 1/2 is the slope. And then now I've got y equals mx plus b. I'm going to stick that in there. And let's use 4 and -2. So -2 is my y. I'm getting that right here. M is 1/2. We already know the deal here, right? For parallel, perpendicular, or neither, don't we? Because if the slope here is 1/2 and the slope here is 1, well, it's not equal nor perpendicular. So this one's going to be neither. But let's just go ahead and just finish this anyway, just to practice writing an equation of a line. So what is 1/2 of -2? That's -1. And then I'm going to add 1 to both sides. B equals -1. So my equation for this one's going to be y equals 1/2 x minus 1. So these right here are neither parallel, and they're not perpendicular either. So that one didn't work. Maybe the other one works for 10. So 11, there's only 11 and 12 left. There's part A and B. We're writing the equation of the two lines and then determining if they're parallel, perpendicular, and neither. Well, let's just look at I'll just do a little bit here for you. Let's write an equation for line AB. So line AB. So we want to get this in y equals mx plus b form. So here's our b right here. That's -4. And what's our slope? So let's find some points. So let's go from A. Why not? Let's go from A. So slope is going to be, well, let's do the slope first here. We're going to go down 1, 2, 3, 4, 5, 6, 7, 8. So that's down 8. That's a -8 over, so where were we? Just right here? Right there, right? And we go over 1, 2, 3, 4, 5. There's our slope, and our y-intercept we already got is -4. So my equation is going to be y equals -8/5 x minus 4. That's our equation. And now let's get CD. So y-intercept for this is 2. And then we're going from C. So we're going up 1, 2, 3, 4. That's a plus 4. And we're running 1, 2, 3, 4, 5, 6. That's plus 6. So the slope for this one is going to be 4 over 6, or 2/3. And then the b is 2. So this is going to be y equals 2/3 x plus 2. So these two look like they're perpendicular, right? But 2/3 is not negative reciprocal of -8/5. We're close though, but it's not. So this one's neither. This one right here, we're going to see that they're parallel because our slope is down 1 over 3, and this one's going to be down 1 over 3. And this y-intercept here is 6, and this one is 2, so they're different. So this line right here, this is an easy one. It's just -1/3 x plus 6. That's this line. And then this one down here is -1/3 x plus 2. These are going to be parallel lines because the slopes are the same. That's super easy. A little bit easier than A. Okay, this next one, you have to find a parallel line and a perpendicular line given the point and the line. So let's just do this first one maybe. So let's do the parallel line. So parallel lines have the same slope. So let's just look at what the slope is of this line right here. Let's find 2 points. Here's a point right here. Let's go with this point and this point right here. So that goes through exactly on our grid, up 1 over 2. And so we're going to go up 1 over 2 for this one right here, up 1 over 2, put point, or down 1 to the left 2. And then we could draw our line. Like that. That doesn't look good. Let's try that again. And where is our y-intercept? It's right here. It's at 3. So the equation for parallel is going to be y equals 1/2 x plus 3. Now the equation for perpendicular, we need the slope to be negative and reciprocal. So we know that the slope of this line right here is up 1 over 2. So we need to make it negative and then change the numerator and the denominator. Now, we could go from this point and we can go down to over 1, down to over 1, or up to the left 1. But we're going to see that the way I drew this graph here, that it goes off the graph. So we don't know where it intersects unless we extend it, or we take this point right here, which is 2, 4, and we just put it into y equals mx plus b. And so 2 is the x, so let's put that x there. 4 is the y. M is -2 over 1 plus b. So -2 times 2 is -4. And then I have to solve for b. I'm going to add 4 to both sides. So b equals 8. So this is actually going to go up to 6, 7, and 8 up here. And so my equation is going to be y equals -2 over 1x plus 8. Okay, so there you go. You guys can do B on your own for number 12. And you got to do number 10 here that I erased. and some here that I missed. 7 and 8 are special cases. We know what lines look like. X equals 4, y equals -2, y equals 3, and y equals 9. See if you guys can come up with that. Okay, very good. Smack out.